The fastest car factory on Earth takes 30 seconds per vehicle. Tesla's new line is being built to do it in 5. No paint shop, no steering wheel, no workers. When each car is done, it drives itself off the line. To understand where Tesla is going, you need to understand where it already is. Across 4 vehicle factories, Fremont in California, Giga Shanghai, Giga Berlin, and Giga Texas, Tesla has installed capacity to build over 25 million vehicles per year. In 2025, they actually produced around 1.65 million, which works out to a new car roughly every 19 seconds when you average across every facility running in parallel. That gap between capacity and output isn't just about demand. Tesla said it directly in their own shareholder deck. Battery pack capacity remains the single biggest constraint on production growth. Each factory plays a different role. Fremont handles North America alongside Texas. Shanghai feeds China and most export markets. Berlin covers Europe, and Nevada supplies batteries and motors to the rest. Add it up, and Tesla is delivering a fully electric vehicle, large battery pack included, out of just 4 sites, while legacy automakers run dozens of plants to reach similar volumes. Shanghai is the crown jewel of this network. In 2025, it produced over 851,000 vehicles, more than half of everything Tesla delivered globally. In December alone, the factory set a monthly record of over 97,000 cars. Tesla describes it as the most efficient automobile manufacturing facility in the world, producing 1 vehicle every 30 to 35 seconds. It took Shanghai just 30 months to build its first million cars. The jump from 3 million to 4 million took less than 14. And then Tesla looked at that record and decided it wasn't nearly fast enough. The roots of what comes next trace back to a lesson Tesla learned the hard way. When the Model 3 launched in 2017, Tesla tried to automate almost everything at once. The result was chaos. A tangled network of conveyor belts that failed so badly Elon Musk famously slept on the factory floor trying to fix it. Out of that failure came a design philosophy now known inside the company as the 5-step algorithm. Question every requirement, delete anything you can, simplify and optimize, accelerate cycle time, and only then automate. Automation comes last. That sequence became the foundation for every Tesla factory built since. The traditional automotive assembly line is, when you look at it honestly, a strange process. You stamp steel panels into shape, you weld them into a body, you hang the doors, you paint everything, you take the doors back off. You thread the entire interior in through those open door frames because you can't reach anything with the body sealed. You lift the car, marry the battery to it from underneath, bolt in the seats, seal the glass, and then reattach the doors you removed earlier. If anything breaks down at any single station, the entire line stops. Every car on Earth, with very few exceptions, has been built this way for roughly 100 years. Tesla's engineering chief Lars Moravy called this process silly at the company's 2023 Investor Day, and he wasn't wrong. The structure creates bottlenecks by design. It forces humans and robots to work inside a sealed body, limiting how many can access the same car simultaneously. And because every station feeds the next in sequence, one failure cascades through the entire factory. The traditional approach also relies heavily on 2 things that are inherently slow and expensive: human hands and thick wiring. A single car door, for instance, requires sensors for its position, switches for windows, locks, and speakers. And in a conventional 12-volt electrical architecture, each of those components needs its own wire running back to a central controller. A modern vehicle contains miles of wiring harness, and that harness is still largely assembled and installed by human hands. Gigacasting addressed part of this problem. The idea came from a toy Model S that Musk brought to a meeting, a miniature version whose entire underbody was cast as a single piece. His question was simple: why can't we do that at full scale? The answer required building the largest casting machines ever made. Italian manufacturer Idra took on the challenge, and the result allowed Tesla to replace over 100 stamped and welded components in the Model Y's rear underbody with just 2 cast pieces. Reuters reported a 40% cost reduction in that section alone, along with the elimination of around 600 robots from the assembly process. Toyota, which invented the lean production system the entire industry spent decades copying, announced plans to adopt gigacasting in 2023. As of today, no gigacast Toyota has reached production. The unbox process is Tesla's answer to the 100-year-old problem. Instead of building a car in sequence, one enclosed body moving down a single line, Tesla splits the vehicle into large open subassemblies. The front section, the rear section, the sides, and the floor are each built simultaneously in parallel, with people and robots able to work on every surface from every angle at once. Nobody is crawling inside a sealed body, threading wires through door frames. Then, in a single final step, those modules come together into a finished vehicle. Tesla calls the efficiency gains here operator density and space-time efficiency. The practical translation: more workers and more robots can touch the same car at the same time, in less physical space. A problem at one module no longer freezes the entire factory. The other subassemblies keep building in parallel. Tesla projects this approach shrinks assembly floor space by 40%, cuts labor requirements by 30%, and reduces production costs by up to 50%. The Cybercab is the product this process was designed around, and it's engineered to be as manufacturable as possible. It's roughly 14 feet long, noticeably shorter than a Model 3. It has no steering wheel, no pedals, no door handles, and no charge port, because a robotaxi can't plug itself in. It charges wirelessly over an inductive pad it drives onto independently. The body panels are polyurethane with color molded directly into the material, which eliminates the paint shop entirely, a first for any volume vehicle. The structure comes together from approximately 80 parts, compared to around 200 for a Model Y. The Cybercab also runs a 48-volt electrical architecture combined with Ethernet-connected controllers, which eliminates most cross-vehicle wiring and removes a significant portion of hand assembly from every unit. At the Tesla all-hands meeting in March 2025, Musk described the Cybercab line this way: "It doesn't look like a car manufacturing line. It looks like a high-speed consumer electronics line, one that eventually moves too fast for people to stand safely near it." His stated target: one car every 5 seconds, ultimately. The first production Cybercab rolled off the Giga Texas line on February 17th of this year. The gap between what Tesla is building and what everyone else is building is not subtle. Waymo leads the robotaxi industry in paid rides, approximately 500,000 per week, but runs a fleet of only around 3,000 vehicles. Each one is an existing Jaguar I-Pace, retrofitted with sensor hardware that Waymo's co-CIO has said adds roughly $100,000 per vehicle on top of a base car that starts around $75,000. Every unit is modified after production, not purpose-built for autonomy. Tesla is targeting a complete robotaxi for under $30,000, purpose-built from the ground up, off a line designed to produce them by the millions. Even at a camera-only approach that some consider a limitation, the manufacturing cost differential is the actual competitive weapon. On the labor side, Tesla is building toward a workforce that doesn't need to be hired. The Fremont lines that produced the Model S for 14 years are being dismantled right now to build Optimus, Tesla's humanoid robot. The reasoning is straightforward. A line moving too fast for humans to safely work near needs workers that aren't human. Optimus uses the same computers and neural networks that power full self-driving, trained through demonstration rather than step-by-step programming. Tesla has stated a design capacity of 1 million robots per year at Fremont, and a second facility in Texas targeting 10 million annually. Competitors including Figure, Boston Dynamics, and Hyundai are all moving in the same direction. Figure's robot logged roughly 1,250 operating hours at a BMW plant in South Carolina over 11 months. Boston Dynamics is targeting 30,000 Atlas units per year by 2028. The entire industry is converging on the same idea: factories where robots build the products, and eventually, robots build the robots. Here's what the math actually looks like if Tesla's stated numbers hold. Their current installed capacity is 2.25 million vehicles per year, adding even the low end of Musk's projected Cybercab output. 2 million units annually brings the fleet average to a new car every 7.4 seconds. At the high end, 4 million Cybercabs, total output reaches 6.25 million vehicles per year. One new car every 5 seconds across the entire company. And if a single Cybercab line reaches that same 5-second cycle time on its own, it matches the combined output of every factory Tesla operates today. The constraint that matters most, though, is the same one Tesla identified for today's factories: battery cells. You can design the fastest line in history, but without enough cells to power the vehicles coming off it, speed is irrelevant. That's why Tesla's dry cathode process, which reduces battery production floor space by up to 50% and cuts electrode manufacturing steps from 10 to 3, is just as important as the assembly line itself. Whether this arrives on Elon's timeline is a separate question. The Cybertruck showed up 4 years late. The Model 3 nearly bankrupted the company during its production ramp. But both of those products eventually did arrive, carrying the innovations they promised. The factory Tesla is building in Austin right now is not a concept. The line is running. The cars are driving themselves off the end of it. The only question left is how fast the ramp climbs, and whether it looks more like Shanghai or more like Fremont in 2018.